Mm, Good afternoon, everybody. And today I want to talk about shear force and bending moment of simply supported beam. So we have a simply supported beam. We have a support at A and support at B, and it has a point. It has a what? It has 2 point load. You have 10 kilonewton at point C and 20 kilonewton at point D. And between A to point C, we have 2 meters. Between this point C, and this is my point D. So it is between A to C, you have 2 meters, and between C to D, you have 2 meters, and between D to B, you have 2 meters. So in the previous calculation, we were able to calculate the reaction at A, which was is equal to 13.30, and the reaction at B is equal to 16.67 kilonewton. So now you have the when you have the reaction, now we can proceed to go look for what? For the shear force. So we shall have go for the shear force. This is the shear force. We want to look about the shear force. The shear force. So we shall use the sign convention that we shall use, that because we are starting from the right to the left, so the upward forces will be negative, and then the downward forces will be positive. So we start at shear force at B. So shear force at B is equals to, now at B it is an upward, so it will be negative 16.67 kilonewton. And then you have shear force at D. Shear force at D is equals to negative 16.67 kilonewton plus what is force at D plus 20. So you can input that in your calculator. I have minus 16.67, then plus 20. You get is 3.33, which is equals to 3.33 kilonewton. Now shear force at C will be equals to 3.33 kilonewton plus point load 10 kilonewton. So you have should be equals to 13.33 kilonewton. So then shear force at A is equals to 13.33 kilonewton plus the reaction at A. But at A it is what? It's an upward force, so it is negative. So it will be 13.33 minus 13.33 kilonewton, which is equals to 0 kilonewton. So the shear force at B 16.67 kilonewton. The shear force at D is 13.33 kilonewton. The shear force at C, the shear force at D is that 3.33 kilonewton, and the shear force at C is 13.33 kilonewton. The shear force at A, it is what? It is 0 kilonewton. So we can go to look at what? The bending moment. Here, look at the bending moment. The bending moments. So we start with the bending moment. So the bending moment at A, we shall start from B to A. So the bending moment at B, it will be 0 because we only have a reaction at B, but we don't have a load. So it will be 0. Bending moment will be 0. Then so from B, then you have the bending moment at D. It will be equals to, now you have a force here at B. You have a reaction here at B, which is what? Which is 16.3, but it travels to a point of what? 2 kilonewton. So it will be what? It will be a positive moment. So it will be what? It will be RB times 2 meter, which will be equals to, what is RB? 16.67 times 2 is equals to 16.63 half 16 of 16.67 times 2, get 33.34 kilonewtons meter. So from point B. Now you can go to bending moment at from point B, bending moment at B, bending moment at C. At C, you have RA times not RA, have RB times 4 because this RB have out of C times 4. Then you have plus negative 20 times 2, isn't it? Negative 20 times 2. So you have RB. So you have, what is RB? RB is equals to RB 16.67 times 4 minus 20 times 2. If you open the brackets, 20 times 2, so 16.67 times 4. So you close it into bracket. So you open the final calculator, you open the bracket 16.67 times 4, you close the bracket, minus 20 times 4, close the bracket. It will be negative 13.3. Yes.
Sasa nifanyaje? Niongeze hii cabbage maji tukule?
Okay.
Let me add it. Isn't it?
Negative 13.32 kilonewtons. The bending moment at A. The bending moment at A will be is equals to, start from RB times 6, what's the first step, then plus RB times 6 plus minus 20 times 4, then plus, also you add plus minus 10 times 2. So it'll be RB is 16.67 times 6, close the bracket, minus 20 times 4, close the bracket, then minus 10 times 2, close the bracket. So we put in, so it will be, so that we have, now we have 16, close the bracket, so we have 16.67 times 6, close the bracket, minus 20 times 4, close the bracket, minus, okay, 10 times 2, close the bracket, is equals to 0. Should be is equals to 0, is equals to be 0, because the calculator says just so much of error 0.02, but the other should be equals to 0 kilonewton meter. So this is how we are able to calculate the shear force and the bending moment of a simply supported beam. So from the start, you saw how I was able to calculate the reaction from the previous video. Now I've started calculating. Now I've calculated the shear force. So if you start from B to A when you calculate the shear force, then the upward force will be, from B to A, the upward force will be negative, and then the downward force will be positive. But if you are starting from A to B, then the upward force will be positive, then the downward force will be negative. So, and if we started from point A to B, then the shear force at B will be 0. The same, the bending moment at B and A bending moment at B and A should be 0, because this is a simply supported beam. For simply supported beam, at support, the bending moment, the moment is usually 0. Okay, fine, thank you. Please subscribe to my YouTube channel. I'll be uploading videos concerning about this theory of structures. And thank you, and God bless you.